All right, we're going to get started here. Good evening, everyone. My name's Jessica Storm. I'm a forecaster here at Burlington's National Weather Service office.
And I am Seth Kutikoff, another forecaster here at National Weather Service Burlington.
And I'm Rodney Chai, I'm a lead forecaster at Burlington.
So here's a quick overview of what we're here to discuss. As you all probably know, a widespread heavy rain event did impact Vermont in mid-July, and several other times there were some heavy rain events across Vermont, but we're focusing today on the perhaps main or biggest one on July 10th and 11th, when pretty widespread 3 to 9 inches fell within about 48 hours. And this event includes both flash flooding and transitioning into major river flooding by the end of the event. So I'm going to go over some meteorology involved leading up to this event that helped cause this to occur. One main feature was that there was some high latitude blocking, something we call an omega block, kind of based on the shape of the Greek letter, as you can probably tell. Essentially, blocking in the atmosphere can cause a bit of a traffic jam, more or less, where that high pressure is very strong and not really going to let the low pressure behind it go anywhere. So the atmosphere is moving very slowly or not at all. And the longer the low pressure can kind of sit over our area and dump rain, the more rain we're going to measure. Another feature of this event that helped it be as potent as it was is that there was a jet streak or area of very high winds in the atmosphere, helping to strengthen that system right there. And the way that the winds were kind of positioned helped really strengthen the storm as it headed into our area. And then third, we had a lot of rich moisture in the area. You can't really have rain without water or water vapor. The surface was very moist with dew points in the upper 60s, lower 70s. And then precipitable water is something we use kind of to measure moisture more vertically in the atmosphere. So kind of moving above the surface was also very saturated with 1.6 to 1.8 inches of water there.
So when we look to message a big event like this, we often will make comparisons or analogs to previous events. In this case, for recent events, it was something that we were doing with a tropical system that had some similarity with regards to the expected rainfall footprint. Although this recent flood was not tropical, Irene does have some similarities. And as you can see on the plot on the right, some areas actually saw more rainfall within especially central portions of Vermont, and then other areas, especially into the Adirondacks, actually saw quite a bit more rain with Irene. And then a non-tropical system that had a remarkable similarity was about 50 years prior. And this was a similar scenario where, to some degree, we had just rich moisture overrunning a stalled out boundary, just basically right over our area, or basically a mixture of tropical, non-tropical, but rich moisture that just keeps overrunning that boundary to the east. And in this case, you can see on the right, there was pretty substantial damage in Ludlow, Vermont, which is an area that obviously was hit hard with our most recent flood as well. So now we're going to jump into the forecast leading up to the event. So we're going to start with 2 days prior, or within basically the 36-hour forecast time frame. So we were looking at here on the left is a hydrograph, basically a river forecast for, this is the Winooski River at Essex Junction. And it was an example of a location in which we had a forecast of flood stage by Tuesday morning. So in this time range, as you can see, the end of the plot is still that is going up. So that kind of tells a story that we are forecasting minor flood damage, flood level, but it could definitely still be higher. And on the right, you can see the rainfall map at the time. And so typically forecasters will want to have continuity and basically build up rather than flip-flop or start too high with regards to precipitation to keep a consistent message. So in this case, initially we were advertising a widespread heavy rainfall, and 2 to 4 inches, localized 5 inches gets people's attention. But as we moved forward in time, we saw that we may have even more rainfall. And so these are products that the Weather Prediction Center, the National Weather Service headquarters, that center provides these products that tell us the excessive rainfall outlook or the risk of flash flooding. So the red area, as we moved into Sunday and then for both Sunday and Monday, we're showing possibility of some significant weather where we'd have numerous flash floods across the area. And this is this is noteworthy. We typically don't see this type of risk for our area. And that is, in some degree, it's based off of some of the model guidance we were looking at. This is Sunday morning, so this is before the event had begun. The storm total precipitation this is showing, essentially, because it's a 48-hour forecast. And at this point, we were looking at areas that could see in excess of 4 inches, pretty consistent with that forecast map we had before. And here you can see it zoomed in. And then this is another forecast. So this is from the same time, but it's giving what is called a probability matched mean, or it's, in other words, the worst, a reasonable worst case scenario, taking a bunch of models and it picks out some of the higher end, basically some of the wetter model that it will lean towards to give you a sense of, as a forecaster, what could happen. And so what it does is it gives us some of those higher amounts, now up to 7 inches in a wide swath in those orange colors. So as we all know from what actually happened, this was a pretty good first forecast, really, for the potential high-end rainfall amounts. It captured pretty well and in roughly the correct area in terms of where the heaviest amounts were. But of course, it's not perfect. For instance, it looks like it was a little bit too far to the west, the heaviest rain. And so then our official forecasts, which again take into account some of that model data for Sunday morning and then Sunday afternoon, we trended that upward from those two forecasts. And again, this is just ahead of the event. So this is really in the important planning time period where we were talking what we were seeing in terms of the meteorology, and the forecast amounts for precipitation were definitely trending upward.
So yeah, thank you, Jess and Seth. And you know, I'm sure a lot of you know, in the weather enterprise, it is really a team sport, and it really includes a lot of stakeholders, including, you know, ourselves in the National Weather Service, and then we have the, you know, different offices within the agency. So we have the Weather Prediction Center, the WPC, the Northeast River Forecast Center, and we also have you know, our partners from emergency management, and as well as our TV meteorologists friends. And so, you know, it takes a whole village to get the word out and to ensure consistent and clear messaging, because ultimately you can put out the best possible forecast, but ultimately people need to be able to understand the forecast in a way that allow them to act and safeguard their life and property. So as confidence grew in the days leading up to this historic flooding, and we use the word historic very sparingly, and it, you know, based on, you know, the forecast, the increasingly dire forecast that Seth talked about, and the meteorology, the anomalous parameters that Jess talked about, it gave us increasing confidence that this is going to be a historic, a potentially catastrophic event. And eventually, we will show you, eventually we started using the word Irene, because Irene was one of the worst recent disaster for the state of Vermont. And ultimately it's all about, ensuring consistency and clarity in the messaging and communication. So one, social science best practice, for those of you who may not be aware, increasingly the National Weather Service has hired social scientists to ensure that we, we are well aware of the latest research in social science best practices. And because ultimately communication, it's not just about pure science, but it's also about social science and humanities. And ultimately you need to engage the ethos of the, you need to engage a person. And in this case, how does the norm, someone, with, regardless of his or her meteorology background, understand the message. So in this case, this is clearly a multifaceted, very complex event. And we try to use infographics like the one that you're seeing right now on the screen. So one of the features of this infographic is, if you look at the bottom right corner, there are 5 different colors. So it's green to magenta. And green represents little to no impact. Magenta or purple represents extreme impact. So you can see in this, with this graphic, Sunday night into Monday, there was the window for extreme impacts, and that was when basically, the overnight crew that worked Sunday night, they essentially put the entire state under flash flood warnings. The situation was very dire, and then eventually the flash flooding transitioned into river flooding because it takes time for the main stem rivers to respond to all the water that eventually drain into the big rivers. So this was kind of like a prolonged event, but for people who live along the rivers, who live in flood-prone areas, it is flooding nonetheless. And so we made it clear that even though the flash flooding threat has subsided, the river flooding threat remained well into to Tuesday. And so we, in this age, social media is also often our, it's in fact the primary way of information, of how people get news. And so it's important that we stay active on social media, be it X or Meta or Facebook. And so when we issued the flood watch, we made sure that the graphic made it out to social media, and we use plain language that people who live along the rivers on the screen, like Osable, Winooski, Mad River, and Otter Creek, needs to be on heightened alert for not just a few hour window of potential flooding, but days. And what kind of flooding? Significant and widespread flash flooding is expected Sunday afternoon through Monday. So again, we make sure we use plain language to communicate the severity of the event. And so on Sunday morning, July 9, the forecasters, and it really is a total team effort, work to coordinate what we call a high-risk day 2 excessive rainfall outlook in conjunction with Weather Prediction Center. And high risk is basically the highest possible risk level for the excessive rainfall outlook. And as Seth mentioned earlier, that's the potential for flash flooding. So in this case, a high risk ERO means that there's potential for widespread flash flooding. And also, it was the first high-risk ERO ever issued for NWS Burlington forecast area, which comprises of most of Vermont and northern New York. And so here's again the graphic, the description of the different categories on the left-hand side, and the actual ERO on the right-hand side. You can see much of Vermont into parts of New York were in the high risk, and then pretty much most area except for St. Lawrence County were in the moderate risk. And this was the day one excessive rainfall outlook. The WPC brought it pretty much all the way to the Massachusetts border for the high risk ERO. And you might ask, okay, so what's the big deal about WPC high risk excessive rainfall outlook? The short answer is that they are a big deal. High risk excessive rainfall outlook are only issued by WPC on 4% of days, but these days have accounted for 40% of all flood-related fatalities, as well as 90% of all flood-related damages. So when the Weather Prediction Center put out a high-risk excessive rainfall outlook, they don't do it lightly, and they only do it after close coordination and a lot of conference calls behind the scene to make sure that we are all on board with this high-risk excessive rainfall outlook. And again, you know, different ways, and you know, this is a graphic we put out on social media, and really we basically went all in to you know, different ways to communicate and emphasize the life-threatening and catastrophic nature of the flooding. And as I alluded to earlier, this is a team sport. So, you know, there's a lot of coordination and communication with our partners, emergency managers, TV mats, and you know, people like yourself, the public, you know, and when we work together, we can help to greatly mitigate the impacts of this historic event. And despite damage rivaling benchmark storms in the state, and like Seth mentioned, Tropical Storm Irene in 2011 and the Great Flood of 1927. And, you know, we will say this, I mean, one death is too many, but for an event like this, we're thankful that we know that there's only one direct flood-related fatality reported. So, and this would not have been possible without, you know, the team effort from everyone. So on July 9, during a Vermont Emergency Management Conference call, forecasters used the word historic and catastrophic, and I emphasize that we don't use these words lightly to describe the flooding that was about to unfold. And the forecasters unambiguously stated that the impacts would be the worst seen since Irene. And words matter. So later that afternoon, Vermont Governor Phil Scott declared a state of emergency. And the state of emergency declaration facilitated the mobilization of swift water teams, not just from Vermont, but also from other states as well, to mitigate storm impacts. And here are some of the, you know, the tweets taken from Twitter or X, and you know, on the left-hand side is Governor Phil Scott, and then on the right-hand side that's our retweet or repost from, you know, with regards to the river forecast for the Winooski River in Montpelier. And some of you know Montpelier, the capital of Vermont, suffered a lot of flooding damage.
So with regards to the river flooding, as Rodney was alluding to, the Montpelier River flooding with the Winooski certainly was the biggest national news story for quite a while, beyond just a regional story. But as these hydrographs show, there were several locations at multiple rivers in our forecast area that also crested at major flood stage, and this did not even include ones that reach moderate and minor flood stage, which can also, and does, in this case, it did create some significant damage in the low-lying areas that fall in those basins. So it was quite a large area, as you can see, either include the Lamoille, the Winooski, the Missisquoi, the Dog River, Otter Creek. So it was quite a bit of coverage across our area that over time may not have immediately been noted, but over time, those areas have been, at least they are known about in the weeks that followed this event. And so now we're going to each share a little bit about what we experienced on the ops floor. So just quickly here on the left side, you see a picture of handwritten information. Basically, you can see in the left column, it's our flood warning products. So those are shorthand for various rivers and their expiration date times for when those statements on the river flood warnings would have to be updated. And similarly, on the right-hand side, this is for our flash flood warnings. We have basically for those, we just keep track by number. So you see the numbers 19, 21, 23, and 24. And so this is just a way that on the floor, we all are, you just look up and you see these, the reminder of what is out there in terms of the most essential products that we issue. And below that, you can see information about the Vermont emergency management calls. That on this day, this is Tuesday, when that river flooding was ramping up. You can see there were multiple calls at 5 a.m., 7:30, 8, and 8 a.m., for instance, on that day. And on the right-hand side, you can see a view from a workstation, which has many monitors, which allow us to both make our forecast and to have situational awareness of what's going on outside of the forecast process as well.
Yeah, I mean, you can see kind of on the image on the left, on the right, sorry, the image on the left with all those screens. I think a lot of people might not know how many screens we have going on at a time, not even including the situational awareness board in the top left corner of that photo that runs through news cycles and webcams, satellite images, things like that, all to kind of keep us up to date on what's going on. So we might have an image of the train tracks washed out on the roads. That was a big image that was shown a lot on the news. Meanwhile, on that leftmost screen on the computer, keeping track of our aviation forecasts, all the regular forecasts that we do on a regular basis continue to have to be updated while we're keeping track of those flood warnings and updates for flood watches, river and flash. You can see on there the calls, the briefings that we did several times a day. So one person would be kind of designated to do a lot of briefings and interactions with the public and with media, a lot of phone calls during the day, questions on social media. It was just a very, very busy time with all of the urgent weather going on.
Yeah, I think Seth and Jess have really say a lot of great perspective. I think it was a very crazy period. At one point we were all thinking, when is the faucet going to stop or stop dripping? But I think for myself, I think as a lead forecaster, I think the team, I'm just really thankful to work with such a dedicated group of people, very selfless, and people, even though people have worked like, let's say 7 days in a row, they
13.
still 13
days in a row some people are working.
you know, like Jess said, they still ask, you know, how can I help more, you know, and to the point the managers have to say, you know, you need to take a break. And you know, all I want to say is that, you know, if you're a member of the public, this group of forecasters is, you know, truly dedicated to the cause, and they truly care about the safety of the public whom they serve. And it is, you know, be rest assured, you know, this was a historic, you know, potentially catastrophic event, but you have a very dedicated group of forecasters who, you know, work day and night, 24/7, you know, with the sole mission of, you know, keeping the public informed, keeping the public safe. So, but I also want to give a shout out to, you know, I saw there's some hydrologists from Northeast River Forecast Center, and you know, folks from Weather Prediction Center and TV meteorologists, emergency managers. This would not have been possible, you know, keeping the number of fatalities, injuries to the absolute minimum for an event like this would not have been possible without everyone's contribution. So I think from the bottom of our heart, you know, we really thank everyone for making it possible, and the public too. You know, we appreciate that you take our forecast seriously, our warning seriously, and then take the necessary actions to safeguard your life and property. So thank you.
Sending us reports when it's safe to do so. We really appreciate them.
Yeah, so, you know, because, well, Governor Phil Scott declared a state of emergency, and, you know, unfortunately, the event turned out to be as bad as we predicted, as we messaged. And so the President of the United States, you know, they, in conjunction with FEMA, they approved an emergency declaration for the state of Vermont. And to this day, the recovery effort is still ongoing. So, so this for people who have lost, you know, maybe lost their property, maybe we'll show you some examples later. This is still an ongoing process, and it would take you know, months, if not years, to for some communities to recover fully. So this was certainly, you know, like on the right-hand side, to the damage in Vermont, you know, was truly devastating, and the people will need support, you know, for an extended period of time. But like I said, this, you know, this is a true team effort to make sure that we get the word out and get, you know, keep people safe. And you know, it's, you know, rebuilding is tough, you know, but at least people's lives were saved. So as we alluded to, the limited loss of life can be attributed in part to the partner interactions well in advance of the storm, accurate forecasts, and again, the proactive steps taken to raise awareness of the severity of the storm in the days before its onset.
Okay, I think we're gonna go over some more of the impacts here. Just to start out, we have the rainfall amounts, 48-hour total. As you can see, a lot of it fell across the greens, but of course, a lot of that ran off and into the streams and caused a lot of river flooding outside of that heaviest area as well. So it was pretty widespread for impacts. Here's an image from the Vermont Agency of Agriculture, Food and Markets. And I'll bring up some other contributions from them later. But you can see this is, Vermont's capital. It's a huge deal to kind of look at the drastic effects that we've had across the state.
And so for the last few photos, were all related to the well-publicized Okemo flash flood event. And this was an example of the swiftwater rescue teams that were staged being doing such a wonderful job to help out, and they were staged and obviously were needed in that area with quite a extensive flash flood event. And so the scale of the flooding can be seen nicely with this data point here in time in the early morning hours on July 11th, just how many road closures, and this is only state and US highways, and just that sheer number and new closures being reported just over a 2-hour period that is listed there of 6 different roads in various locations across central Vermont really illuminates the scale of the impacts for sure within this event.
So here's before and after photos of the community garden plot from my neighbor Allie. She sent me these, and I thought it was kind of showing that even areas like Chittenden County, portions of Chittenden County that didn't really see that high rainfall amount, like we got only 2 to 3 on the periphery of the highest amounts on that map, 2 to 3 inches. There were still impacts felt far beyond that area of highest rainfall, partially because this is due to the Winooski River flooding. And so there are many, many farms, gardens, and trails right on the Winooski at the Intervale that were flooded. And you can see on the photo on the right, taken shortly after the flooding, all the debris and dirt kind of collected on those plants that have been literally underwater. So it's just kind of showing the expansive impacts across the state. And on the next slide, I have some quotes pulled from various places, including that Vermont Agency of Agriculture, Food and Markets, talking about just thousands of acres of farmland in Vermont have been lost. The Intervale Center, as you saw earlier, saw total or near total crop losses. And I believe that the near total crop losses, part of that is because people at the Intervale were going there in the rain, pulling their crops, trying to harvest as much as they could before the Winooski rose enough to flood them. And they were able to do that, and seeing the river forecast and seeing what time it would be unsafe for them to be there because the river was going to flood. And we had the river forecast out showing the timing, the magnitude. And so people were able to get there, pull as much as they could before everything was submerged. Because after it's submerged, there's a lot of toxic chemicals in the water, sewage issues that occurred, just part of the damage that occurred in that area. So not only can the crops not be sold or eaten, it's also a reason why, we encourage people not to swim in floodwaters. It can be very dangerous to get in the floodwaters. There are all sorts of dangerous things in those waters, and the soil is now all contaminated, and farmers are not able to farm for the next few months in some places. So a lot of you on here may know even more other impacts that we're not even aware of. You may be dealing with this personally in both monetary value and emotional. There's some estimated losses for a small farm, chickens drowning, and while there was only one known human death, there were animal deaths, as this stated. This chicken farmer that lost all their chickens. So it's an emotional, it's monetary, takes a toll. So that's a little bit of an intro to By the Numbers, but we have a few more numbers if you don't mind. Kind of wanted to bring back the rainfall amounts. Our highest amount was over 9 inches in Calais, Vermont, which is very impressive. And Montpelier just broke a daily rainfall record from Irene with 5.28 inches. And then you can kind of take a look and see it, all the 4 to 8 inches, pretty widespread there. I think that the folks here that made this graph had to change the color legend to allow for the sheer amount that was reported, because our legend didn't go that high. So thanks to those that made this beautiful map. And then just kind of pulling back a bit and looking at July overall, it was the wettest month on record in Montpelier, and potentially other places. It's hard because not everywhere has a location that reports and records rainfall. But we can compare Montpelier all the way back to 1948. You can see we reached over a foot of rain throughout the entirety of July with this event, and then following events where, like Rodney said, like when is the tap going to turn off? When is it going to slow down? It just continued to rain.
Yeah, so we so what you're seeing here is basically, this is the monthly calendar for July 2023, and so what is plotted on each day was the day one excessive rainfall outlook, and as we touched on earlier, that is issued in conjunction, issued by the Weather Prediction Center in conjunction with the forecast office like ourselves. And so it's from an impact scale, there's four levels. So it goes from marginal to slight to moderate to high, and this was the notice July 10. That's the high risk excessive rainfall outlook, which represents the potential for widespread flash flooding. And once again, this was the first high risk excessive rainfall outlook issued for the Burlington forecast area, and you can see that even outside of that, this main flooding event, the whole month of July was just a very wet and brutal month for Vermont and really much of New England. So we have just counting off the calendar, so there are 4 moderate risks, and then there are just dozens of slight and marginal risk excessive rainfall outlook. So it's and you can think about it from a hydrologic standpoint. Not only is did we get a lot of rain in a short period of time, the grounds were saturated, so they were not necessarily being able to take on more water. And so basically you are just pouring salt on wound at that point. So it just made for a kind of like a prolonged period of disaster. So really until we get like a prolonged drying period, we get the soil to dry out some, and fingers crossed, we hopefully have turned the corner with the recent stretch of nicer weather. July 2023 would be a month that wouldn't be forgotten by Vermonters, for in a hurry. And so.
And thank you, Amy, for bringing up about Barry got a downpour on July 7th that saturated the ground, leaked into basements before the big rain. Kind of as Rodney was talking about, you can see on this image that July 7th had a slight, July 8th had a marginal, 9th has a moderate. So it's the whole month was very wet, and not only were there events after this one that caused the month to be so wet, but there were precursor events, precursor flooding in some areas that helped set the stage for this bigger type event that recorded these high amounts in that 48-hour, but it was a long haul.
And so this is another way to look at the month of July by what is roughly an approximation of departure from normal. Since we plot on a map here, we don't have long-term data. All these locations, it's interpolated, connecting some areas that do have data. So the general idea, though, it definitely showed up that it was in a large swath of Vermont and in portion of northeastern New York, more than 200% and a lot of 250% of normal. So a lot of locations had essentially normal summer's worth of rain in the 1 month. And Montpelier, of course, our climate sites stand out at 282% of normal for the month of July. So it was, yeah, the numbers, again, they certainly are impressive.
And then kind of to end it out, I did discover this dashboard from the Agency of Agriculture, Food and Markets, and it's an updating dashboard they have. So this is kind of a screen capture of it, how it was, but they are taking information from a lot of farms across Vermont. As you can see kind of in the pie charts, it's mainly small farms, some medium farms, and a small amount of larger farms, by the numbers at least. But they asked them things like feed shortage, problems with feed quality, this is just kind of a look at what some are experiencing, what some are estimating. Addison, Bennington, Chittenden have some of the highest estimated losses. And while, like we said, Chittenden didn't necessarily get those higher amounts, it is very highly populated, so that may be playing a role as well, and maybe contributing why Franklin, Essex may have lower numbers, just with lower population and lower amounts of infrastructure there to be lost. But one thing that sticks out is as well is that the question, do you have crop or livestock insurance? It's about over 70% said no. So this is overall, I think in general this summer, July mainly, but it's a running tally with some more by the numbers. And then we'll kind of go to the summary. So as you know, the widespread heavy rain, and a third look at our rainfall map. And this was a very impactful, terrible event. But we believe that the good communication, good coordination, and the use of our accurate forecasts to emphasize how damaging it could be may have helped limit loss of life. And that this was not a standalone event. Kind of in comparing it to Irene, my understanding is that it was rainy and then it stopped. This event was ongoing. Multiple days had rain after this, and multiple days had rain before this. And then questions? We'll give it a couple minutes for typing time.
So if you have a question, the recommended way is to put it in the Q&A section of your dashboard, so everyone can see your question, and then we can make sure that it gets addressed.
Hi, sorry folks, we're just gathering our thoughts. There's a lot of questions, so we'll try and get to all of them.
Well, as of now, there were like we mentioned, every single death is hugely regrettable and unfortunate. Officially, from our office standpoint, there's one fatality so far that we can attribute with confidence to the flooding, and that was the hiker in this case. And the other fatality, which happened in a basement, there were still more investigative work still needs to be done. But nonetheless, we want to emphasize that each death was regrettable, but at the same time, we were thankful that we were able to help save lives with our messaging and forecasts. So how long until this happens again? This is a question by Jim. And so, I wish we know the answer. And so I do want to say that, so I remember reading an article that, and it was actually a couple who lost their, who had a total loss for the restaurant they were trying to open in Ludlow. And they moved up from another state. And they were saying, well, it's, Irene was like a 1 in 100 year event. And so sure, probably wouldn't happen for another 100 years. The terms like 1 in 100 years, 1 in 1,000 years, it's important that folks don't take the numbers literally. Doesn't mean that 1 in 1,000 years it wouldn't happen again until year 3,000, but it is a description. Put it this way: it is a description for it is a probability messaging. 1 in 1,000 year event or 1 in 100 year event, it's unlikely to happen on a frequent basis, but doesn't mean that it couldn't happen. It's just a low likelihood event. And we have seen there's been evidence of increased frequency of extreme weather with, in this case, climate change, and studies have shown that, while not, well, the link couldn't be, well, you couldn't link an extreme event necessarily to global warming or climate change, but climate change has been shown to increase the likelihood of extreme events, be it more extreme heat waves, more extreme flooding, or even extreme cold. And so, you know, and for us as forecasters, for us, you know, in the weather enterprise, you know, our job is to put out the best possible forecast to help protect life and property in conjunction with our partners. So, regardless of you know, people's beliefs in climate change, I think we can all agree that preparation, we all need to be prepared for the increased frequency of higher end events, and I think this is you know, this Great Vermont Flood of July 2023. I think it's Exhibit A example of how when agencies, when you know, work together, everyone selflessly contribute to the cause, we can bring the impacts to the minimum. So, well, in a nutshell, well, we couldn't predict when the next big event is going to happen, but be rest assured that the Burlington Forecast Office has a group of dedicated forecasters who will work tirelessly to make sure that you know, we protect the public to the best of our abilities in conjunction with our partners.
So someone asked what can Montpelier or another spot, etc., do to avoid flooding during the next excessive rain event. And I think there's a few different layers to that. You can't necessarily avoid flooding if it's going to occur, but there's ways to be prepared for it, and there's ways to be aware of where you are, if it's where you're living or where your business is. We often talk about floodplains in rivers. Like, for example, the Intervale is in a floodplain, and that provides them very rich soil that helps them with farming, but it is much more likely to flood in excessive rainfall events. So being aware of, if you live in a floodplain, things like that, if you live in a flood-prone area. And there's also just being prepared, being weather aware, having ways to receive warnings on your phone or other things like that. Having a plan on if there is excessive rain expected, if there's a flood watch out, kind of planning for what you might do, things like moving to the top floor of your house or evacuating the area, kind of dependent on what local officials are suggesting at the time. Do you guys have anything else? Okay. And I think that, Rodney, you kind of addressed that. How often can something like this happen in the future? Is it the new normal? Refer to what Rodney just talked about.
With regards to the question about the mudslides and landslides, I believe VT Digger ran a story just the other day talking to some geologists about this. So it's not really in the wheelhouse of a meteorologist. And so we're learning as well in terms of the numerous landslides that have been triggered by the flash floods in recent weeks. And so I'd probably refer you to the Vermont Agency of Natural Resources that has a department that studies this and has a better handle on the link between the hydrology and those mudslides that have been occurring. So it definitely has been quite an impact with the heavy rainfall, though. We're well aware. Okay, so the question from Lawrence is a good one with regards to the difference between flash flood guidance and excessive rainfall guidance. And indeed, there is some overlap. So essentially, the flash flood guidance is a very specific term that meteorologists will, or hydrologists are creating something that a meteorologist will look at that is over a period of time, for instance, 1 hour, 3 hours, or 6 hours, that for any given location, how much rainfall will trigger a flash flood. And so the excessive rainfall guidance, to some degree, will be elevated when the flash flood guidance, or the amount of rainfall that is needed to call the flash flood, when that decreases, when you need less rain, then it will cause, if with nothing else changing, it will cause excessive rainfall guidance to go up. However, the excessive rainfall guidance is also a product of how much rainfall is forecast, right? So the idea that you can have an increasing rainfall forecast that can be deemed excessive, and you still are in a state, for instance, where it's been dry recently, where you might be more concerned just in terms of getting to a higher, basically, for instance, often just a total of 3 inches in certain areas will be excessive, right? And so it might not be related to necessarily the flash flood guidance. So again, they're very similar, but there's some subtle differences. Oh, and this question from Erica is very interesting. For this is gets into kind of the meat of meteorology with regards to what makes a forecast accurate. So when you look at a map, there is going to be what forecasters will do, will verify our forecast for every location, and we can make a difference map. So just taking the observation and subtracting what actually happened. So observation minus forecast is a difference, right? So in this case, the forecast for Calais, that was quite a bit less than what was observed. So generally speaking, we unfortunately, for individual location, you may see these errors, and that's just the nature of the atmosphere. It is, you could argue it's unpredictable from that point of view, that for a specific value. However, with regards to the bigger picture of the high end potential that we highlighted with areas getting greater than 7 inches, that did play out. In this case, Calais was on that eastern edge, and the footprint of the very heaviest rain wound up shifting a little bit east, like areas, for instance, in the Western Champlain Valley, where the opposite happened, where they had forecast values that were higher, and wound up getting less rain. So generally speaking, we wouldn't say that the forecast was unpredictable. It's more that the degree of accuracy that for a particular location is very challenging on the state of the atmosphere to nail down for any given particular location, especially on the edges of area of heavy rain.
Yeah, I feel like sometimes when we're forecasting, there's a point in time where there's a heavier amount of rain or snow, and we're just like, we know that it's going to fall somewhere around here, and somewhere else right next to it might get ripped off. And so it's difficult to line up where exactly that heaviest band is going to be.
Yeah, and Erica, and I would add that, we try to tell people not to focus on the bull's eye of the forecast. It's just like in winter, you don't forecast, people attention, you get immediately drawn to the, where is the maximum, the bull's eye snowfall amount. And like Seth and Jess have mentioned, the forecast models have come a long, long way in even just the last 10, 20 years. And they've become very accurate. But it's impossible to pinpoint exactly where it's going to fall, the highest amount of snow or highest amount of rain. But I think, and that's why the excessive rainfall outlook is so important, because it is almost kind of like it's an aggregate of the information. Like we know that, you know, it doesn't matter whether it is, you know, whether you get 5 inches or 9 inches of rain, you're going to see widespread flash flooding.
The impacts are more important than the numbers.
Absolutely, yeah. So that's why we call it impact-based decision support services, or IDSS. And that's, if you look at the mission of the National Weather Service, that is the, you know, like the most, I guess, the most important thing that we would, you know, when we put out each forecast, that's what we try to achieve every single day. So this question by Alan is, does the NWS anticipate any changes or updates to the emergency alert system, or EAS, as a result of this series of events? The short answer is that we don't, there is no plans to change it as far as we know at this time. So by Vera, so do you monitor lake levels? So we do monitor Lake Champlain level, and this is the lake that by Newport. So, and we did take, I believe we issued a flood warning for the Newport area, and that's actually a result of the lake level being high, and you know, unfortunately, it did. In this case, the annual swim has to change locations. So how many staff members were in the office during the peak rain event time frame? A lot. So it felt, you know, I would also give a shout out to, so NWS Burlington is part of the NWS Eastern region, and we have folks from Eastern Region headquarters actually they're down in Long Island. They actually came up for a few days to help us out, and we're grateful for their help. And you know, the other thing to consider is that people go on, you know, have like planned vacations in the summer, the summer peak leave, and so you know, there were, so you know, different factors led to you know, the office being relatively you know, I guess short-staffed for an event as historic and catastrophic like this. So but you know, all the people who were available, you know, all put in dozens of overtime, you know, dozens of hours of overtime, and then we brought in extra resources from the Eastern Region headquarters as well to, and basically we, you know, I'll give you a number. It was like 8 to 10 forecasters.
Yeah, I don't know exactly the number.
Yeah, but it's just basically all the workstations were taken, and you know, but it's all hands on deck.
Could the wildfire smoke have played a role in enhancing the precip amounts? No, not to our knowledge. It would not have played a role. Oh, and thank you, Haley, for mentioning that no major soil contamination has been found at the 9 farms tested by the UVM extension. That is indeed good news. And then I guess we'll go back to cumulative rain has fallen since June 1st.
Yes, so I know certain areas in Vermont, for instance, Rochester, Vermont, some of the ripped in certain areas in central Vermont that have seen the most rain, have seen more than 26 inches of rain since late June. If you recall, the first part of June actually was quite dry, so you could even start on the summer solstice and move forward from there, and it would be a similar answer. So yeah, there have been over 2 feet of rain in several locations in central Vermont.
I think, so Elizabeth asked the question, has the climate crisis made forecasting more difficult? I wouldn't say it's made forecasting, the day-to-day forecasting, more difficult. I would say that if the climate crisis has increased the frequency of higher end weather events, then there will be greater likelihood of having more all hands on deck moments like this. But this is what we are why we study meteorology for, why we get into the weather service. So I think we take this in our stride, and I think once again it's a team effort by not just by the NWS Burlington forecasters, but also different departments and different offices within the agency. Northeast River Forecast Center, Weather Prediction Center, Eastern Region Headquarters, and our partners from emergency management and TV meteorologists. So it's like with teamwork, everything's possible.
El Nino.
And with regards to any impacts that El Nino will have in Vermont, weather for the fall in particular, this ability to predict just based off of the signal from El Nino is rather low for weather impacts. The seasonal conditions are driven by a combination of factors, including the blocking pattern that Jess mentioned in the beginning of the presentation with regards to blocking pattern upstream, which we've seen over the summer, which has helped create this wet pattern we've seen. If that was to continue with El Nino, then that would promote continued wetter and cooler conditions. But unfortunately, we don't really have the ability to accurately predict that in this time range. So the impacts could be quite variable through the course of the fall and similar into the winter.
And I do like to direct people to the Climate Prediction Center site. They do seasonal predictions of cooler, warmer than normal, more precip, less precip that you can look at. I think that's all the questions.
And if you have, we appreciate people who, 27 people who stayed past 8 p.m. We know that your time is precious, but we truly appreciate you spending the evening with us, and we hope you have answered some of your questions. But if we have left you with more questions, please feel free to, in your confirmation email, you would have the email address that you can send questions, or you have comments, good, bad, things we can improve on, or even like suggestions for future webinars. If you want to find out more about teleconnections, drop us an email, say that you want to see a webinar on teleconnections in the future. We will try our best to have a webinar and try to engage. We like to engage the public. Without the public, without you, we wouldn't be able to get the word out and help save lives. So yes, just thank you very much.
Yeah, thanks for coming, everyone.
Have a great night.
Oh, yeah, okay. Have a good night.